Today the webinar is on IEC 61508, Certification of Mechanical Safety Equipment. Just a little housekeeping. There is a questions tab on your panel. If you have any questions, please type into the panel. I will wait until the end of the webinar and read the questions out, and then if we have to go back in slides, we can do that without a problem. Also, we're recording this webinar and we have a copy of the slides. If you signed up for the webinar today, you will be emailed a copy of the slides later this week, and the recording will be available on the Exida website and the Exida YouTube channel. Today we'll talk about IEC 61508 and how mechanical equipment can be certified for safety applications. We'll look at the step-by-step process used to certify a mechanical device and explain each one of the processes, as well as what to expect when preparing for the certification process. Just quickly, my name is Loren Stewart. I'm a CFSP, graduated from Virginia Tech and started in manufacturing right out of college. Now I work for Exida. I work primarily in the mechanical customers, and I do safety certifications, the FMEDAs and the safety cases, along with a lot of research and publishing reports and white papers on stiction and mechanical failure rates. We have offices all around the world, so no matter where you are or your customers are, we have somebody close by that can help you with any of your functional safety needs. The Exida has 4 main industry focuses. We have our OEM, our engineering contractor, our system design side, and our end users. And we have 3 main product and service categories. We basically do everything that involves functional safety. So whether it's the process, the products, or the people, we have consulting, engineering tools, product certification and training, reference material, and personnel certification. This is an example of the Exida certification. This is what you end up with at the end, a certificate, and that's what we're going to be talking about today. The Exida certification process has an established scheme for functional safety and cybersecurity. We're going to focus on the mechanical certification process today. We also have the personnel, products and components that we look at during the certification. The functional safety certification involves a detailed analysis of both the engineering process and the design margins, resulting in random failures, and you receive a random failure rate in all failure modes. We have a lot of reference material available, which we're very proud about. We like being a very transparent company, so all of our processes are documented in different white papers and books and webinars. So we like to be as transparent as possible so you know exactly what we're doing when you are working with us. Quickly, a little bit about engineering tools. We have our Excellentia tool, our SIL Alarm, which is our alarm rationalization tool, our SIL-STAT, which is field failure data collection analysis tool, and our CyberFacts, which is our cyber risk assessment tools. So today, the certification of mechanical equipment, IEC 61508, what does it mean? We're going to break it down into different topics. We're going to look into the introduction to IEC 61508. What is it? Why is it important? Who really cares? And why you probably should the initial certification request. What do you do when you want more information about the certification and what you should expect? The different certification paths that you can choose to take depending on the different level of information you have on your product or device. And we're going to look step by step into the certification process in detail. So let's start with, what is IEC 61508? IEC 61508 is commonly referred to as an umbrella standard. It is the international performance-based standard for all industries. Then IEC has broken up into many categories that fall underneath IEC 61508 for a special or more specialized subset of rules and regulations, such as IEC 61513 is for nuclear, IEC 62061 is for machinery, and the process industry has IEC 61511. So if you make a mechanical device, you would certify your product to IEC 61508, and then your customers would use IEC 61511 when taking your device and putting it into their system. So you both follow a slightly different path of rules. One is for end users and one's for manufacturers, but they all cover the same information in the same ways. IEC 61508, its main goal is to achieve functional safety, and it defines functional safety as the automatic safety function will either perform the intended function correctly, or the system will fail in a predictable or a safe manner. So the performing the intended function correctly, that's reliability engineering. And safety engineering is looking to make sure that the system fails in a predictable manner. IEC 61508 was created when a bunch of working groups and national standard bodies from all around the globe came together to work in a process to bring together to make an international standard. People from DINV 19250, which is the German draft national standard for safety-related systems. Also DINV VDE 0801, which is the Principles for Computers and Safety-Related Systems. That's another German national standard. Those both came about 1990-ish. Also, S84, which is the application of safety instrumented systems for the process industry. That is an ISA branch. Then you also have your EWICS, or the European Workshop on Industrial Computer Safety, and your HSE PES, sorry. And that's a branch from the UK, which is the Health and Safety Executive Guideline on Programmable Electronic Systems. So everybody came together to create one international functional safety guidelines so that multiple countries didn't have multiple set of rules and go back and forth. This is one place that you can find all of the information for functional safety. A lot of people say, well, who cares? Why do you really need a standard? What's the big deal? Well, there's a couple different ways that the standard is needed. And the first one we're going to look at is to provide a safer working environment for people. So we basically want the standard to save lives. And these are a couple U.S. statistics. Well, in 1 year, we had 5,703 workplace fatalities. And as you can see, fatalities in manufacturing facilities were 459, giving you a fatality rate. And that's something that IEC 61508 wanted to address and wants to lower so that there are less workplace fatalities and that people in those environments are safer. The standard also wants to protect investments in plant and equipment and to ensure continuous operation. So in doing both the ensure continuous operation and protecting investments in the plant and the equipment itself, it's to save you money. So as you can see, these are a lot of U.S. statistics, once again, from 2001, looking at different values of property damage. And this is just looking at property damage only. And these companies, as you can see, could have saved a lot of money. That's a lot of money just to be throwing away. So IEC 61508 wants to make sure that you're not just throwing money away. And you want to protect your plant and equipment. And finally, IEC 61508 wants you to avoid OSHA fines. So as you can see, in 12 months, there were 54 OSHA inspections in the United States. There were 415 citations and almost $10 million in fines. That, once again, is a big hunk of money. So in using IEC 61508, you'll be able to create a safer environment for your employees, and also you will save your company, you could save your company a lot of money. You could protect their investments and hopefully avoid OSHA fines. Looking at IEC 61508, it's broken into two fundamental concepts. The safety life cycle, and that's the detailed engineering process, and the probabilistic performance-based system design. When thinking of the safety life cycle process, you're dealing with the systematic faults. So that would be the design, documentation, mistakes, process mistakes that you can be correct by changing a process or a document or a design. On the other side, you look at the probabilistic performance-based system design. That's hardware reliability or random failures. One of the key objectives of IEC 61508 is to address accidents caused by creating a system to manage safety. And this is to assure proper technical requirements and to assure competent personnel are working on it and using it. So users will require certification bodies to use IEC 61508 to certify equipment per technical requirements, per processes such as your functional safety management process, and personnel, which is through the certified safety engineer. A lot of people look at the standard and see the EEPE and think, well, the first E is electrical, the second E electronic, the PE is programmable electronic. That means, well, I have a valve or an actuator. I have a simple mechanical device. So that means that IEC 61508 doesn't relate to me, right? My suggestion to those people are just Google it. Take a look, and as you can see here, I Googled IEC 61508 and mechanical elements. The first link that comes up is a link to the IEC website and the FAQ page. As you can see, question number 4 relates to it. So that's a question that's asked often. So let's zoom in on that a little bit. IEC 61508 talks about how it's IEC 61508 is applicable to any safety-related system. So, being a simple mechanical device, you might not meet every single requirement of the standards, such as you might not have to do the portions related to code or to testing software, but you still need to meet the requirements that are hardware related. So although you might not check off every single box in IEC 61508, you still need to check off plenty of them, and the standard is still used in simple mechanical or type A devices. A study of actual industrial accidents looking at their causes, was done by the Health and Safety Executive in the UK. And they were able to break it out into the number of causes. The most significant was basically from poor functional safety, or the functional safety specification, and that was equal to 44%. Other causes included changes after commissioning, or including online changes, at 21%, the operation and maintenance errors, 15%, installation and commissioning errors, 6%. So there were problems in almost every activity leading to operational safety instrumented system. However, it was apparent that a better method, there were needed multiple methods, or a better method in the front end of engineering process as well as the back end to make all of functional safety safer. So it appeared that the life cycle approach was not being used in design, and IEC 61508 really uses the safety life cycle approach in looking at their systematic faults. So IEC 61508, you're able to address major issues. Three of the most issues that are causing accidents are safety management, technical requirements, and competent personnel. And IEC 61508 Safety Life Cycle addresses all three of these areas. And going through the safety life cycle, you then are presented a certificate at the end that you have looked at all of those areas. From that, the accidents are actually lowered. So what is the certification? What does certification programs mean? Well, this is an example of a certificate that you would be presented at the end of an exida certificate. We look at systems, products, components, and personnel. Our certification process is a third-party assessment done against a set of requirements based primarily on international standards, or IEC 61508. Functional safety certification involves a detailed analysis of both the engineering process and the design margins, resulting in random failure rates in each failure mode that it could possibly be in. Once again, we look at cybersecurity if involved, but being a simple mechanical device, I doubt that you're going to need the cybersecurity end of the certification. Who does certifications? Well, we always say certification programs have been established by private companies and governmental bodies all around the world. And all organizations who perform certification should be accredited for their field of work. So every certification body should be accredited by a third party. Just as we're saying you should be accredited by a third party, we hold ourselves to that same standard. We have ANSI come in and audit us to make sure that we are doing what needs to be done independent of us looking at our own process and say, oh yeah, we're fine. So we're doing the exact same thing we're making you do, and we are accredited by ANSI. ANSI is a international, well, the American branch of the international study. Oh, here you go. Exida is fully accredited per ANSI, the United States IEC liaison, as a certification body for both cybersecurity and functional safety. And this is our ANSI certificate for our Exida branch. And being ANSI is from the IAF, most countries around the world recognize an IAF certification. So it ensures that everybody using MLA or IAF accepts and knows the same level of standard is throughout. And because we're proud of our ANSI certification, we display it boldly on our certificates. Any IAF certified accreditation body will put their certification, their IAF certification on the certificates. IAF rules allow the certification body to show the accreditation body logo on the certificates for all work done under accredited procedure. So now that you know a little bit about IEC 61508, we're going to look at what happens when you want a certification. How do you start that process? Well, when you contact Exida, the first thing we do is say, okay, here is our application. Please fill out all of the blanks. Send us a product brochure or an IOM, or any other useful documents that would help us gain knowledge about what your product is and what you need to do for this certification. Once we have all of the information back, including the application, we then create a quotation with our quote number and our proposal, and we send that off back to you. After you receive the proposal or quote, we do an initial call to welcome you, to go over any questions that you might have, tell you what you need to expect the process to be, and how to get started and what your timeline is like. So now we're going to look at the different certification paths that each company or each device could take in certification. So to understand this, IEC 61508 has two different product types. It's defined as Type A and Type B product certification. The Type A is, well, that's the official definition. It's easier to say it's a simple mechanical device, and a Type B is a smart device. So everything can kind of be put into those two categories. Of course, there's going to be exceptions, but those are the main criteria. IEC 61508 says that there are 3 different ways to show your systematic capability. And systematic capability, if you remember, is the way that your design process, your modification process, your documents, everybody's following the right things. That's what systematic capability has to deal with. So you can choose Route 1S, Route 2S, and Route 3S to demonstrate how you are systematic capable of whatever device you're saying you're going to make. There are, out of the 3 options, the first is a design test procedure that is fully compliant, design and test process that is fully compliant for changes, and a device that you cannot make changes to. We'll look at these a little closer. So the first option is a new product design. There's no field history, there's no shipments, no returns, or very few. So what we're going to do is we'll look at the new design and make sure that you have a hardware failure analysis. That would be the FMEDA done. We will make sure that the new design must follow the design process requirements of IEC 61508 for whichever targeted SIL level that you choose, whether it's SIL 1, SIL 2, or SIL 3. And a safety manual must be created to explain how you intend your customers to use your product at the system level correctly. So as you remember, the FMEDA is the random failure integrity. The process or design would be the product systematic failure integrity, and the safety manual allows for a system systematic failure integrity. The next, so here's what the flow chart looks like for a new design per the exida flow chart. As you can see, all the way to the right are the documentations we expect you to provide. Some of those are type B, so you wouldn't be providing those, obviously. And on the upper left-hand side, those are the reports that you would receive. And in the middle is all of the things we are talking about today. Option 2 is a product with well-documented field history. Once again, we will still look to the design and then must have a full hardware failure analysis. So once again, your FMEDA. The product field data collection process, we will audit that. And if quality data is available, it is analyzed to show that there's a lack of design problems. We'll also look at your design process to meet all of the requirements for IEC 61508 for ECNs or ECRs, your modification process, your impact analysis to make sure that everything is good to go. So if you make any changes, you can incorporate those changes without having your certificate revoked. And then finally, the safety manual must once again be created to explain how to use the product at a simple system level. FMEDA is random, your process is product systematic, and the safety manual is systematic. Now going through and taking out some of the portions that we no longer need to look at. Obviously, the software module test plan and software related tools are not going to be applicable for simple mechanical devices. And now looking at the third option is a product with well-documented field history. So that's the same. Once again, we're going to do the design must have a full hardware failure analysis, the FMEDA. The product field data collection will still be processed and audited. If quality data is available, it will be analyzed to show lack of design problems. But this time, instead of looking at your modification process, your ECNs, your ECRs, and your impact analysis, now we're just going to say no changes are allowed to be made. So we don't need to look at those process and documentation. But we still will need a safety manual, just as in before. FMEDA, random. Your process, product systematic. And your safety manual is system systematic. So as you can see, there's a lot more things that are not needed when there's no modifications made. So now let's take a look at the certification process. What happens step by step, and answer any questions you might have about it. We're going to start by looking at one of the conventional certification process. Everything on the right-hand side is done by the manufacturer. Everything on the left-hand side is done by the certification body. So the manufacturer in this case will be responsible for the FMEA or FMEDA. You'll be responsible for your own safety case if you have any software analysis, that as well. You need to make your own FME or FMEDA report. Your safety case reports, if you have software and communication report. And once you have everything done, you hand it back to the safety or the certification body, where they simply look at and audit the safety case and issue a certification. But instead, we're going to take a look at the exida certification process. And as you can see, that line has shifted a lot. So as a manufacturer, we just have you provide your documentation, what you probably already have. And then exida preforms the FMEA, the FMEDA. We make the baseline safety case and any other audits that need to be done. We create the FMEA, FMEDA report. If software is done, we take care of that as well. And then once all the requirements are met, we then issue an assessment report and certificate. So once again, we're going to look at the life cycle, and in so this has removed a bunch of items that won't necessarily be applicable to a type A or a simple mechanical device, such as a valve, an actuator, solenoid. So even though IEC 61508, it still needs to be done for a simple mechanical process. There are some steps which we talked about earlier that don't necessarily need to be done. So we're going to look at the portion circled in red to begin with, and that's the start of the project. Exida starts off by asking for a functional safety management plan, a safety requires specification, which for a simple mechanical device could simply be your product bulletin or IOM. If the main function is the safety function, that's sometimes not a separate document, and that's okay. We also will look at validation test plan and test results if this is a new design. If it is a design that's been out there for 60 years, we don't expect you to have that information, and that's okay. We'll look at tool justification if you're a software type B product. We're going to look at a safety manual, which a lot of times if you are new to functional safety or IEC 61508, most people don't have a functional safety manual, and we can help you create that. We can't do it for you, but we can show you what we expect to be there and what we audit to make sure it is there, along with any shipping and field return information. After we're done looking at the baseline safety case or the gap analysis, we will do an on-site audit. We'll come to your facility, we'll give you a IEC 61508 training, which we say anyone who touches a SIL-rated product come. We can help you understand how to market it better. We can help you, everybody, possibly even on their shop floor, understand why It's so particular for a seal-rated product, and all of the things that the engineers did to make sure that this product doesn't change. So everybody's on the same page on what it means to be seal-rated. We'll do a manufacturing plant tour, and we'll review any action items that might be open. And we can answer any questions that you might have. At this point, you might say, hey, Loren, we don't have a safety manual. What do I need to have on this safety manual? And I can let you know some of the things that we are going to be auditing for. Or we can even say, well, here's a template that's published in this book. Go here to find it. And we'll talk to a couple of engineers or other personnel, basically making sure that the work being performed actually excuse me, actually matches the documentation. So now we're going to go further in the exida certification process and look at the baseline safety case and the final safety case and what those are and what they mean, along with the random failures and how we achieve your random failure rate with an FMEDA and what reports are associated with those. And so a lot of the times we get asked, what does it mean for product development? Well, IEC 61508 basically says we need to have a documented life cycle for safety, a requirement for safety-related functions, and there is a need for a safety-related validation plan. These points in red are for software, so we're not going to talk about that today. When a certification is being assessed, we create a, we have a tool and we create a safety case. In our safety case tool, we have broken down every single requirement from IEC 61508 for the targeted SIL level that you're trying to achieve. From that, we break it line item by line item and say the requirement in this section of the standard, this paragraph, is met by this document that the manufacturer has, this paragraph, even this sentence, and this is why it does. So we make an argument and we have your supporting evidence or your document for that argument. And once everything is completed and all of the arguments have been taken care of and any action item taken care of, and we have a evidence and argument for each requirement that's required, we then publish an assessment report. So the safety case is broken up into different sections. You have your goals, your requirements, your arguments, your evidence, and then the report. So the goal for the safety case is to provide justification that a system or product is safe. Provide one document for many certification authorities. It looks to make sure that you have your safety project status immediately visible, and as well you can offload the development team from the compliance work so you can keep on working on your regular jobs and give us the task at putting the evidence and arguments for each requirement. Because we work on this every day, we're able to do it faster than you would be able to do it if you're learning IEC 61508 for yourself. So the safety case is broken up into system scope and description, the safety claims, so that would be the evidence, the allocations to a system or subsystem, the arguments or the evidence, and the conclusions if there's any limitations. When we are analyzing the information for the safety case, we also take a look at manufactured field return studies. So you're going to hand us your shipping record and your return record with any return information you have, and we'll be able to create a proven in use history, a proven in use study for you. And that data is very important, especially if you're going to be using your proven in use justification for your systematic requirements. We take that and use it with a prediction failure rate. What we do is we developed a FMEDA technique which predicts failure rates and failure modes of a product. We're able to do that by seeing your drawing and your bill of material and breaking it down for every O-ring, every bolt, every washer, and using our component database with the component failure rate and the failure mode distribution, and see how, if that O-ring leaks a little, what harm does that do? Okay, that might be no big deal, but what if that O-ring leaks a lot? Well, is it going to be a dangerous failure? What if your valve needs to rotate and shut the process down, and it can't do that? That would be a dangerous failure. What if it shuts the process down without turning? That would be a safe failure. So we take a look at all of the ways things can fail dangerously, safely, or what if it's just leaking into the environment? Well, we would consider that an external leak. That would not necessarily be safe or dangerous, but if you had something in the process that could be a hazard to people's health, you would then know that it is an external leak. So from the FMEDA, you are given a total failure rate for the product, a product failure modes, and a diagnostic coverage. FMEDAs is a study of design strength. So every failure mode of every component is examined with detail in a systematic analysis of hardware and the impact of automatic diagnostics. So the method is very systematic. It identifies real problems, but requires many engineering hours. And it really relies on the component database a lot. My mom always told me, garbage in is garbage out. So if you don't have a validated component database and you're doing your FMEDA from a database that has not been calibrated all the time and doesn't have a lot of information in it, you're going to get failure rates that really mean nothing. And then your customers will take those failure rates and do calculations of their whole systems using garbage failure rates. So that's a big no-no. So the failure rate data is given by Exida in different applications and in different ways. So as you can take a look here, Exida has the same device in different modes of application. So a deionized to trip and an anodized to trip application. So ways that it can be used. We also look at if there's partial valve stroke test or if it's a normal testing. Then we give you information about if there are safe detected failure rates, safe undetected failure rates, dangerous detected failure rates, and dangerous undetected failure rates. And some of the important information actually comes from the safe detected and safe undetected failure rates. It's something that not everybody does, and a control engineer from the U.S. chemical industry has said that a false trip rate is essential in our design parameter of our SIS design. How can I do this without that data? And only exida certifications provide both the dangerous and the safe information and break it apart into so many applications. So from exida certification process, you will receive a FMEDA report that is generated, and then the baseline and final safety case are generated once the gap audit or any action items are complete. So that then takes us to the certification being issued. And the exida reports would be the actual certificate itself and the assessment report. So here's an example of each. On the left is the certificate itself, and on the right is the associated assessment report. When you are receiving your assessment report and certificate, we then publish that on a website called the SAEL, and that is a very useful website. A lot of end users use this website to use as their equipment selection source. And what you do is go down at the top and you go through elements, and then you can go pick which element you need. Say you're going to go elements, final element, valves, ball valve, and you will see a list of all ball valves published. Well, here's the list of all ball valves published, and on the right-hand side, where the exida logo is, where the exida logo is, clicking that will give you the certificate, the assessment report, whose product it is, what model, a description, and if you want to, we can even list a website or a hyperlink to your description, and it can go straight to your product's website. And we saw a study, and we were quite surprised when we saw the study, that exida has provided over 90% of the certifications for process, industry, and field equipment. We were excited when we saw that, and like I said, we were surprised, but we were happy to see that. So you can do the same thing for something like a gas detector, and you can see all of the ones done for gas detectors. Same thing for logic solvers. And then, if you'd like to, we can also do a news release for you. We can work together with our marketing team, works together with your marketing team, and we can create a news release that would go through our email list that we could send all of the news release to, that you can also send it out. We can also publish it in our monthly newsletter. So those are all things. We don't just give you a certificate and dump you out and say, hope this was fun, thanks. We want to work with you and make you be marketable and help you thrive with this certification. So a couple benefits for both being an end user and a manufacturer with the exida certificate. If you're an end user, you can clear you can clearly see the safety integrity justification for the selection of the equipment. When you go on to the SAEL, you click which ball valve you're looking at. It will not only list the SIL level. If you click the certificate, you can also see the failure rates on the back of the certificate. Then you can click into the assessment report and read all about the product description. You can see all about their safety functions and any limitations that the certificate might have. It's a good predictive failure rate for a system design, and you will receive your complete safety manual. You'll have all of the information you need in that safety manual that you can just take this device and know exactly how the manufacturer needed it to be run to qualify for functional safety. Being a manufacturer, you also have a lot of good benefits. First of all, you can say that you had a third party and they said, yes, we have a high design. Yes, we have a great manufacturer quality and a documentation process. This isn't just you saying that. This is somebody completely removed from your world doing this. And that goes a lot more further with your customers than it would just if you said, yeah, I think this is good, I'm stamping off on it. It also, you are going to reduce field failure rates and reduce design flaws. You will receive market recognition because exida is globally recognized as the premier certification body, and exida has issued more process industry certifications than any other CV. And finally, that marketing support that we just talked about. You will have your product placement in the SAEL website, but also in our Excellencia. It's that tool that we briefly discussed in the beginning of the webinar. A lot of end users are using our Excellencia tool when they are doing their safety system calculations. And having your product placed in Excellencia they can easily, in a drop-down menu, say, oh, I need a ball valve that is SIL 2. And it lists all of the ball valves in SIL 2. Or I'm using this valve already, what actuator can I use with that? And then they can run all of their safety calculations using different valves, actuators, final elements, all of that. So instead of having to manually type in all of your information, you're already going to be a part of Excellencia software. So are there any questions at this point? Yep. Okay, let me see here. Okay. The first question can you make a safety case by including proven in use to be applied to any target SIL, or is it limited to a maximum SIL? And how can we validate proven in use? Number or products in the field. By time in the field, when we don't know that data is valid. Let me start by the first part of the question. What we recommend is if you do not know your intended SIL level that your products are going to be used in, we suggest you do the best or the highest SIL level that you can achieve. And then you can go for SIL levels below that. If you know the maximum SIL level your product is going to be used in is a SIL 2, great. Just be SIL 2 capable. But if you don't know what your customers are going to use, we always suggest to get the highest skill level that you can achieve, and at that point you can use, say you receive a SIL 3 capable, you can be used in a SIL 3, a SIL 2, and a SIL 1 capable product. And then it says about validating proven in use numbers. What you would do is send us your proven in use data and we can validate it. We do the calculations for you. We have standard calculations that we do and programs that we use to make sure that the data and the time is valid, with averages on if this is the average amount of time it sits on the shelf before it gets put into use, and so on. Is the certificate suitable for framing and public display? Absolutely. We actually send you a framed certificate that we encourage you to display publicly. So after you are done with your certification, we will send you a nice care package. We send you a marketing kit, and we also send you a framed certificate. The next question is, I think that owner of running plant needs to record any failures of safety equipment as part of the SIL loop to ensure the actual lambda DU value is less than the considered value in the SIL verification done via the Excellentia tool. Means the consumer needs to reconfirm those values of mechanical equipment as well, isn't it? And I'm assuming you're talking about end user look here. When you are putting together your entire SIS and using the Excellentia tool and doing SIL verification, we always suggest that you relook at the numbers at the end to make sure that your assumptions are always correct. No matter if you are mechanical or software, we want everybody to make sure that the assumptions made for SIL verification in the beginning are the same assumptions at the end, and if they're correct. And as well, when we are doing products, we confirm that the proven in use numbers from the field return and the shipment isn't way out of whack compared to the failure rate. The next is, such exida failure rate list is very helpful for consideration reasonable values instead of too optimistic values. Thank you. Oh, that wasn't a question, that was a statement. Well, you're welcome. I'm glad that you find it a realistic approach, and that's what we like. We hope to be slightly conservative so that you're never in a position that you are found in an unfortunate situation because of too optimistic values. That's something that we always want end users to take a look at to make sure that they are doing a reasonable approach instead of thinking that your system won't fail for 10,000 years. Does exida also focus on such final elements like MV switchgears? I have not done any. Per my own experience, I can ask if anybody else has, but I have not seen any in the time that I've been at exida. And then, so IEC 61508 can be applied to strictly mechanical devices. Absolutely. Once again, you just do not use the portions of IEC 61508 talking about coding or software. We use IEC 61508 for strictly mechanical devices such as valves and actuators all of the time. And it is something that we think should be done. And then how is it different than 13849? 13849, I believe, is the machinery standard. And the machinery standard is actually machines that are in high or continuous use applications. IEC 61508 is taking a look at functional safety. And 9 times out of 10, the functional safety is actually in a low demand mode operation. So that is a different view of the world, so to say. Are there any other questions? Okay, so if I do not have my valve certified, is there a website or someone that I can ask to know what the failure rates should be for my product, an approximation, so to say? Actually, there are. There's a website called www.sillsafedata.com, and that gives you a general feel of where each application should be. Once again, you can see, say, final element, I'm looking at a ball valve, and it will give you a range where you should see. And if, it depends on the complexity of your valve or your actuator, your device. But you can know that you can fall somewhere in between those two. And this works for both if you're designing a product and want to know about where you would be, or if you're an end user, you want to use this product in some of your calculations. Say they're going through the process being certified and you want to know about what you can assume. Or if you receive a certificate that has the wildly optimistic failure rates that we just talked about, you can use that as a sanity check. You could say, okay, this valve is seeing at range between 300 fits and 800 fits, but I received the certificate that it says my valve is 1 fit. Well, that can be a red flag, and that's a great it is www.sillsafedata.com, and you can use that information to both know about where your product is going to be, but also where you can do checks on different applications if you receive a certificate that you think might be a little too optimistic, or if you're buying a valve and they're going through the process of 61508 and you want to know about where they're going to come in. Once again, it has to deal with the complexity of the device, but that's a good range to know what to be in. Well, I hope everybody enjoyed the webinar, and thanks for attending.